Okay, here we go with Unit 3, Lesson 8, graphing polynomials from factored form. Our objective is to sketch the graph of a polynomial from factored form and identifying the real zeros. So if you remember on the 3.7 notes, I asked you to add this box, the factored theorem, to the notes. So here it is again. So in Unit 7, we use the factor theorem to show the binomial is a factor of the polynomial. Show that the binomial here is the factor of the polynomial, then factor the function completely to find solutions, roots, zeros, X-intercepts. Remember, these all mean the same thing. They're interchangeable, synonymous terms. So we're going to use synthetic division. Again, we set this equal to 0 and get x equals -4. So -4 is the number we're going to put in our box. It is already in descending order, but we are missing a squared term. So we need to put that in there. Drop down to 1, multiply by -4. Add them together, multiply by -4. Add them together, multiply by -4. Bingo. Since we got a 0 at the end, that means that x plus 4 is a factor of x cubed minus 13x plus 12. It goes into it evenly. Now, we need to write the factored form. So first off, we need to write x squared minus 4x plus 3 equals 0. And then we need to factor it. Guess and check, or whatever method we use. This is going to be a pretty basic one. It's going to be x minus 3, x minus 1. Okay, -3 times -1 is positive 3. -3x plus -1x is -4x. Not reviewing factoring at this point. If you need more practice, ask for help or go to the video on factoring in Unit 2. So factored form, the important thing you've got to remember is don't forget to bring this down here also. So first off, try to remember to do that one first when you start dividing by, and then the ones you found when you factored. Now the zeros are just when we set each of those equal to 0 and solve. So x plus 4 would give us -4. X minus 3 would give us positive 3, and x minus 1 would give us positive 1. I'm not going to do that, but you can do that off to the side and solve for each one. Those are the zeros, and the roots, and the x-intercepts, and the solutions, all the same thing. Set this equal to 0, x is -1. That's the number that goes in our box. We have 2x cubed, we have 9x squared, we have 3x, and then we have -4 as our constant. No need for zeros. Draw our line, drop down 2, multiply by -1. Add together, multiply by -1. Add together, multiply by -1, add together, bingo. No remainder. So since we start with cube, this is going to be 2x squared plus 7x minus 4 equals 0. We need to factor this. X2 is prime, so it's obviously going to be 2x and 1x. The possibilities for -4 are 1 and 4, 2 and 2. And it's going to be 1 and 4 because we need to make 7. 2 times 4 is 8. 1 times 1 is 1. 8 minus 1 is 7. Since we need 7 positives, this is positive, that's negative. So I lied. I did review a little bit of factoring. So factored form, don't forget to start with this first. It doesn't matter if I come first. I'm just trying to make you remember to do it. And then we have our 2x minus 1 and our x plus 4. Zeros. X plus 1 equals 0 gives you -1. 2x minus 1. Add 1 to both sides. 2x equals 1. Divide by 2. X is 1/2. X plus 4 4 equals 0 gives us a negative 4. Those are our roots, our zeros, our x-intercepts, and the solutions. Now here we have a long-winded fundamental theorem of algebra. It says if f of x is a polynomial of a degree n, where n is greater than 0, then the equation f of x equals 0 has at least one solution in the set of complex numbers. Now remember, complex includes all the real and imaginary numbers. So in other words, we're always going to have at least one solution. If we have a parabola, it might hit only once. It could hit twice. It may not hit the x-axis at all, but that's still going to be two imaginary answers, which is in the set of complex numbers. So, if f of x is a polynomial of degree n, where n is greater than 0, so we either have a linear function, x to the first power, a quadratic, x squared, a cubic function, x cubed, then the equation f of x equals 0 has exactly that many solutions, provided each solution repeated twice is counted as 2 solutions. And each solution repeated 3 times is counted as 3 solutions, and so on. So, if we're doing a quadratic, we have x squared. That means we're going to have 2 solutions, no matter what. And for those for example, why is it 2? I thought you said it was only 1. Well, what we're saying is if it comes out and hits once and goes back up, bounces off the x-axis, we're going to count that as twice. Okay, and if you remember me talking about the calculator, will actually sometimes tell you, depending on how you use, what program you use, will actually tell you it's twice, even though it's only one number, because it's specifically hitting on the way down and on the way up. So we can count it as 2 answers. So the highest exponent tells us how many solutions or zeros we need to find for that polynomial. So to graph polynomials in factor form, first we're going to identify the number of real zeros known as the x-intercepts, looking at the highest exponential number. Got lost in the word there for a second. Determine the real zeros by setting the factors equal to 0 and solving. Make an XY table and test values to determine the graph behavior between the zeros and the end behaviors. So this is going to be a little bit more work. And we can use our graphing calculator for this also. We can enter this right in our graphing calculator just the way it is and help us get this information. So the lead coefficient. Well, eventually we're going to multiply x times x times x. Right there. Now we're going to get an x cubed. But it's just going to be 1 x cubed. There's no coefficient out here other than 1. 1 and 1. So our final answer is going to be 1. Now the degree is going to be 3. X times x times x is going to give us cubed. The degree is an odd number. 3 is odd. It is cubic. We've already said that. The x-intercepts. Just set each of these equal to 0. So right here, x is 0. Right here, x is positive 2. And right here, x is 5. Now remember, for the x-intercept, the y-intercept, x is equal to 0. So if we plug 0 in for x, we're going to get right here, no matter what happens in these parentheses, this 0 is going to make y 0. Because it's going to negate everything else we do. So if we put 0 in, we're going to get 0 times negative 2 times negative 5. Well, anything times 0 is 0. So even though this is positive 10, 0 times 10 is 0. So our y-intercept is going to be 0, 0. And remember, we just test that by x equals 0. And we can also look for that in the graphing calculator. Now, if we look at the graphing calculator, we'll just first put our solutions. Here's 0, 0. Here's 2. And here's 5. We look at our multiply table in the calculator. And we get numbers like this. So we put those numbers, the ones that we can put on there, such as 1, 4, and 3, negative 6, and 4, negative 8, now if you look, a negative 2 is going to be way up here, and negative 1 is going to be up here also. So you know that this, sorry, yeah, negative, sorry, they're down here. So what's happening is, negative 1 is going to give you negative 18, so it's coming up, going through here, hitting, going back down, hitting, and going back up. Like so. Preferably hitting all the dots. That's a horrible line. Let's make it thicker. Okay. Now, and you can also graph this in the graph calculator to get a good idea of the shape of it. Now, are the ends of the graph pointing in the same direction? Well, no, opposite direction. One's going to negative infinity, one's going to positive. The ends of the graphs are in which two quadrants? Well, this is quadrant 1 up here, quadrant 2, quadrant 3, and quadrant 4. So we have quadrant 1 and quadrant 3. There you go. Number 2, it's going to be more of the same. The lead coefficient is going to be our negative 2 right here. The degree, well, that's going to be an x times x times another x. Remember that. This is really another x minus 1. You got to pay attention there. So it's really x times x times x. So that's going to be cubic. Once again, cubic is odd. The x-intercepts, the zeros. Well, if you set each of those equal to 1, you're going to get 1 and negative 1. Y-intercept, if we plug in 0, for x, we're going to get negative 2 times 1 times negative 1 times negative 1. If I plug 0 into all three parentheses, 0 plus 1, 0 minus 1, and again 0 minus 1. Well, a negative times a negative times a negative is negative. And 1 times 1 times 2 is 2. So that means my y-intercept is at 0, negative 2. Right here. My x-intercepts are at 1 and negative 1. If I make an xy table, look at my calculator, put this in, negative 3, negative 2, negative 1, 0, 1, 2, 3, I'm already on the chart. 64, 18, there's my 0, there's my negative 2, 0, negative 6, and negative 32. Well, I put negative 2, negative 6 right here. going to hit here, bounce up, and then come back down, like so. Well, using the calculator will help you get a good picture of that. Are the ends of the graph in the same or opposite directions? Opposite directions. Where does it end up? In 2 and 4. 2 and 4. Okay, 2 more of these. So we have x squared, 1x squared times x, which is going to lead to a least coefficient of 1. The degree, x squared times x is going to be the 4th degree, which is even. Type, quartic. Now remember, we should have 4 roots, or solutions, or x-intercepts. Now the x-intercepts are zeros. If we set x squared equals to 0, we get 0. If we set this equals to 0, we get 2. If we set this equals to 0, we get negative 2. And you say, hey, that's only 3. Okay? Well, our negative 2 is obviously once. The 0 is the one that counts as twice, because it's going to bounce, kind of like a ball bouncing, and the x-axis is either the floor or the ceiling, depending on where it's coming from. So it bounces like a ball. So that's actually our double one. And then positive 2. Y-intercept, if we plug in a 0, we get 0 times negative 2 times positive 2. And 2 times negative 2 is negative 4, but once again, this 0 makes it be 0. So we have our y-intercept at 0, 0. We have our roots at negative 2 and positive 2. We do our xy table. Negative 3, negative 2, negative 1, 0, 1, 2, 3. If you go to 4, negative 4 is in the hundreds. So this is 45, 0, negative 3, 0, negative 3, 0, and 45 again. Okay, so it's kind of mirroring. You can see there's mirroring that's going on. So our 1, negative 3, and negative 1, negative 3. So look what happens. This is going up. It bounces off 0, comes back down, hits here, and goes back up, kind of like a W. So are the ends in the same direction or opposite direction? Same. Which quadrants are they going through or ending up in? 1 and 2. Remember, use your graphing calculator for this. Okay, last one. Lead coefficient, right there, negative 2. The degree is going to be x times x. So that's x squared, 2. Type, that is a quadratic. Which also, remember, this tells us 2 roots. The x-intercepts, set this equal to 0 and get 3, set this equal to 0 and get 1. If we plug in a 0, we get negative 2 times negative 3 times negative 1. We multiply those out. Negative 2 times negative 3 is positive 6, times negative 1 is negative 6. So that's my y-intercept when I plug in a 0. So 0, negative 6, 1, 0, and 3, 0. This is a parabola, so we can use our graphing calculator. We can also find the vertex. Remember, opposite b over 2a. Negative 1, 0, 1, 2, 3, 4, 5. Negative 16, Same or opposite direction? Same. Where are they ending up? 3 and 4. Okay? Now, the thing you want to look at is the last 2 pages, last 4 graphs. What do you notice about the opposite, about the end behavior of the odd problems? That's right here. These are both odd. What do you notice about them? They go in opposite directions. And if you look above, what do we notice about the